Hi, everyone. My name's Robert Mosolgo. I'm a Rails developer, like she said. She already introduced me. I'll keep going. I wanted to talk about GraphQL, what it is, and how you can use it with Ruby and Rails. So let's start. Oh, before we start, most of my code samples will be about Magic the Gathering, which is a card game. And if you don't know this game, I thought I would introduce the concept. You play Magic with cards, and each card has a name, and it has some colors. So there's a white card and a green card. They're all green cards. And when you have a group of cards together, that's a deck. Some people, including me, we like our decks so much that we give them a name, like the Goblin deck or the Angels deck or whatever. So anyways, that's what we're working with. So to talk about GraphQL, we should talk about data-driven user interfaces. When I use that word, I'm talking about a screen in your app that has a life cycle like this. First, you render the page. And then you wait for the user to type something or click something. And when they do something, you load some more data from your server. And when you get your data, you render again. And when you render, you wait again. And you have this cycle: typing, clicking, loading new data, making a new screen. I have a simple example. Here's a search box that whenever someone types, we should fetch some new suggestions from the server. So how do we do that? These days, a common approach is to use a resource-based JSON API, where each object in your application has some representation, a collection of fields, that tells the world about this object. So maybe you start by implementing an asJSON method, and you need a little bit of extra stuff. And next month, you need a little bit more. And after that, it looks like this. If you're using Trailblazer, maybe it's better. But next month. So the problem is that your asJSON method gets complex. And it's complex for a reason. It's hard to do. And another problem is that by default, it's coupled to your database. So whatever columns you have in your database, that's what comes from asJSON. And if you change your database, asJSON will also change. And some clients may break your iOS app or something like that. The reason asJSON becomes complex is because we're trying to deal with these problems. One problem is overfetching. If your object has 10 fields, and you send all 10 to the client, but the client only wants one field, you've wasted your time and you've wasted your energy because 9 of the fields were thrown away. Another problem is underfetching, which is to say, if you want all the information about a deck of Magic cards, first you should request the deck, find its name and ID or something. Then you need to request all the cards, and we wish we could get that all at once. So we make asJSON more complex. This is where GraphQL comes in. It's an alternative approach to solving this problem. In a GraphQL system, you have one URL. It doesn't have to be that, but you have one. And you write a query that looks like this. In this query, we're looking for a deck, and we're using the ID number 1. And when we find that deck, we're asking for some of its values: its name, the cards that are in the deck, and for each card, we want a name and the colors. So we send a query like that, and we get a response. Ooh, that doesn't show up very well. This is a JSON response that what I want to show is it has a data key. And then inside that, we have deck, which matches deck over here. We have name, which has a value. It says turbo fog. And then we have cards, which returns an array. And for each card, we have name and colors here and here. So the structure of the query defines the structure of the response. There's no overfetching because we asked just for what we want, and there's no underfetching because we asked just for what we want. There are a few words we should talk about before we keep going. When you ask for the property of an object in GraphQL, that's called a field. So name is a field, and all of these things are fields: deck, name, cards, name, colors. Some fields accept arguments. You can define them that way. This way you take input from the user. And when you have a group of fields together, this is called a selection. So I'll use those words: field, argument, selection. This is what they're all about. So how does it work? You have this query, but how can we turn the query into real data? It works because on your application, you have a GraphQL schema. And the schema is a collection of types. It's a type system that describes your application. So here's my type system. One of the types is deck, and it has name and a rating. If you like my deck, please give it a good rating. And it has cards. Now, cards, you can see, is a reference to another type. So here it is. They're connected by this field. Card has some fields of its own, including a reference to a third type, which is an enum, a collection of related values. And card even has a reference to itself. So this schema is a graph of types, and they're connected by fields. Once you have the type system, you can support some really interesting tooling that you can't do quite as well from a resource JSON API. And one of the best examples is this development environment called GraphQL. This is a browser, and it has 3 parts. I've squeezed them in because I wanted to show all 3. Here is where we're writing a query, and because the type system is well-defined, we can get suggestions and some inline documentation. And then in the middle, here's the response of the query, the JSON that matches the query itself. And then on this side, we have some documentation. As you build your schema, you can include documentation. GraphQL, because it uses the type system, it can save you from making typos, and it can also identify usage errors in your query. So when it comes to figuring out how can you use somebody's API, this is a really nice option. The way it works is because a GraphQL schema, by definition, it has an avenue for introspection. Besides exposing data, it also exposes its own structure. So here's a query that the first selection is __ schema. And this is the way that the schema publishes its own information. What types are in it? What fields do the types have? That's basically it. So here you can see a little example response. To talk about a GraphQL schema, the last question is, where does that fit into your application? If we're talking about a web stack, we usually start with the database. And then we have, there's some Ruby and Rails application. So that's your Ruby code, your classes, your methods, objects. And GraphQL is one layer on top of that. What I want to say is GraphQL doesn't communicate with your database. It doesn't write SQL queries. It really communicates with your Ruby application, so it might be part of Rails. And it communicates with your classes, and methods, and objects. And then any clients who are interacting with your application can use that endpoint. OK, there's GraphQL in a nutshell. We talked about how you write a query, and when you send it, you get a response that matches the query. We talked about GraphQL Schema, which is a type system that is really well defined and documents itself. And we talked about how GraphQL fits into the stack, that it's not connected to your database, but it's connected to your application and everything that's in there. OK, next let's talk about how to use GraphQL inside Ruby. There's a gem for that. And I should be honest, I started that gem, so that's why I'm talking about it. A lot of people have contributed since then, but I have to be honest. You can use the gem to build a GraphQL schema. So you can define some types, you can define the fields on those types, and then you can put everything together into a schema. To use the GraphQL gem, you have an API like this. There's a define method, and inside this block, we do some definition. So here's a name and a description for some documentation. And then we can define the fields of this type. We'll look at that more closely in a second. Here's another kind of type, the enum. It's a collection of values. And you can see that the values are defined inside that block. There are a bunch more types that can be a member of a GraphQL schema. And you can read about those in your free time. Some of the types in GraphQL can have fields. And let's look at what that means. The simplest field definition just calls a method on an object. So this one calls the name method, and we say that that returns a string. We have to tell the schema what type it returns. You can modify your return types a little bit this makes a non-null return type. We say will never be nil, will always be a string. You can also specify that the return type is a list of some other type. So here's a list of strings. This types is a kind of definition helper to declare your types. Types.string is a built-in scalar type. It comes with the GraphQL gem. But you can also make fields that return your own object types or your own scalar types for that matter. All of those fields we saw just call a method on the object and return some value. But sometimes you need more oomph. You need some more logic than that. So you can also define a field with a custom resolve. Here's a field definition, but I really just want to show this part. That you can define resolve, and this is a Ruby proc. This has a little stabby and then some arguments. And the job of the body is to take the object as input and some other things that you can read about in the documentation and return an object of this type. So if your fields need some custom logic, that's how you do it. Another thing that fields can have is arguments. And we saw an example of that with the ID number 1. And here's another field definition. And here's the part relating to an argument. It has the name min rating, and we specify that it's an integer. Then inside the resolve proc, we can use that argument. So this is a way that you can take input from a user, like filtering or pagination, or what else do we use input for? Creating things, actually. OK. So we've talked about types. We've talked about their fields. Now we want to make a schema so that we can actually serve queries. And we need one more thing. The type system itself is a graph, right? This interconnected collection of nodes. But how do you get in? We define a special type as the entry point for the graph. And here it is. It's called query type, and its name is query. And this is the front door, if you will. So we saw an example like this. We queried for a deck by its ID. And here's how you could define a field like that. It has the name deck. It returns a deck. It takes an argument of an integer called ID. And to resolve this field, we search the database for something with that ID. Now that we have our type system and our entry point, we're ready to make a schema. You can define the schema with your entry point, and then from there we discover the rest of the types. And this is also where you can specify error handling and some security things like a timeout. And then your schema can be used to execute queries. So here's a Rails controller action, and the interesting part is here. Your schema has an execute method where you take the query string, and the GraphQL gem parses it and then executes it according to your type system. If you want to use this endpoint, here's a simple way to do it with jQuery. You just post to that endpoint with a query string, and then this handler gets called with the response. If you want to use the graphical editor that I showed earlier, there's a gem for that, but also I wrote it, so, well, I started it, I should say. So I had to say that. It's called Graphical Rails. OK, we talked about GraphQL. We talked about how to use it with Ruby. You can define your types and fields. You can define a schema, and then use it to execute queries. I need to check my time. How's my time? Good. Yes. Great. So I started working on this gem a while ago, and one of the most fun parts for me has been interacting with other developers, using it in different ways than I am. So here's a couple of the Ruby companies that have been asking questions or adding features or complaining. So it's fun to see some traction. I didn't describe earlier that this idea, GraphQL, came from Facebook originally. It's, they used it since 2012 for their mobile applications. And they started talking about it along with things like React.js and now Relay. So it's part of this Facebook idea cloud. And they have a team of people, here they are, some of them, who are always talking about new ideas and describing the way that they use GraphQL and writing reference implementation of this idea or that idea. So I really just listen to what they say and then try to copy it. And I wanted to talk about one idea I have for that that's in the GraphQL streaming gem. So These days, users really want a good experience. That's just the way it is. And one thing that they like is live updates. So here's my Magic Cards deck, and I'm watching to see if my friends like it, and I just want to watch to see how the rating changes over time. So if you like it, please give me a good rating. GraphQL has a construct for that called subscriptions. Here's a subscription query. You can see it looks like GraphQL, but it has this special word, subscription. This says, unlike a normal query, it has a special behavior. The first time you send it, we get an initial response. Here's data, new rating, deck, and you can see the initial value for that field here. But later, we should keep listening, and if the value changes, we should send a new payload. We execute the same query again, and we send the same data. So if you have done, live updates before, you know it has the same problems of overfetching and underfetching. You have to decide, when you push a live update, should you send only the ID of the object and make the client fetch everything again, or should you send the entire representation of the object, even though much of it will be thrown away? So in this way, you specify exactly what you need, and that's what you get. Oh, what did I do? Ruby on Rails 5 has a great new feature for that. It was one of the 9 years of progress items from the last slide. I'm just going to give you a hard time. It's called ActionCable, and it has a pub/sub event system like this. Inside ActionCable, you can start listening for events based on their name. And then in other parts of your application, you can trigger those events by name. So when the event gets triggered, the cable can do something. This way, you can listen for changes and push new information to the clients. So this was a great option for GraphQL subscriptions. Another part of ActionCable is that it sets up a WebSocket connection. And what that means, in short, is that with a kind of normal HTTP, when the client wants more data, it has to make a request and then wait for a response. Make a request, wait for a response. With a WebSocket, it's a little bit different. We have one WebSocket connection from client to server. It's a long-lived connection. It stays connected the whole time. And data can go both ways. So the client can send something to the server can send back, but the server can just push information to the client also. So this also seemed like a good way to support subscriptions because you could just push information to a browser. That's WebSockets. So how would that look for a client? You could define your query string like this. You can define some parameters called query variables that we didn't talk about. And then you can define a function that says, whenever we get some new data for this subscription, here's how we should update the user interface. And then you use ActionCable to bridge the gap. Connect the client to the server and say, whenever this event happens, send me the new data so I can update my user interface. That's what I have in mind. So here's just I guess I'm proving that it works. We're using GraphiCL to send new data to the application, and then ActionCable updates the page by a GraphQL subscription. Another good user experience that I find myself doing more often than I'd like is called reducing the time to first byte. So if you have a screen that's full of data, sometimes, eventually, that screen will be very expensive to calculate, and it will take a long time. And you don't want to leave the user waiting with a spinning wheel like this. So what you do is you send an empty page and let the empty page load, and then you fill the data in. So here's a little example. If you reload this page, the cards in the deck load one by one so that we can have a fast first response and then let the rest of the data come. GraphQL has some experimental feature for this. This little @ sign, this is called a directive, and it allows you to specify how the query should be executed. So you could write a query like this, where some fields are marked with defer. And defer means when you run this query, don't give me these right away, but give them to me later. So you get a partial response that only has the name field here, but it doesn't have these two. And then you get a patch that says, here's the path to the data that I'm sending you, and then here's the data to update with. so the deferred fields can come later. Similarly, there's a directive called stream, which is the same kind of behavior, but it works for a list of items. So if you have a list of cards, instead of loading them all at once, the initial response should send only an empty list, and then subsequent patches can send the items. So if you've ever implemented this pattern by hand, for me, it involves like a lot of jQuery and a lot of requests, and this was a way to simplify that kind of pattern. From a client point of view, it looks the same. You write a query string, and you provide some parameters to that query string. You define a function that says, whenever I get a patch, I want to update the user interface like that. So this function would be called with an increasingly larger response as the patches arrive. And then you connect the two parts with ActionCable. That's how you send. The client sends his query, and then the patches come one at a time over a WebSocket. So here's what I've been working on, and I'm happy with it, but there's still some things to do. I'm not using ActionCable in production yet. I'm a little bit slow moving in that regard, so I'm not exactly sure how that will work out. I'm using it in a way that's unusual. I'm streaming multiple events over one channel, and I'm not sure that's the intended use. And when you have a user interface, like I'm used to having two states. Either it's loading, and we show a little spinner, or it's not loading, and we show the data. Well, now it's loading, and then it has some data, and it has some more data, some more data. So I have to figure out how that should work. And how does the client know if you're streaming a list of items? How does it know when it's received the last one? That's something I need to work on still. But if you're interested, GraphQL streaming also has a defer and stream implementation that uses HTTP streaming responses. So that's a little bit simpler approach. OK, that was about it. I wanted to introduce GraphQL and Ruby and show my experiment. And I hope you're interested. I wanted to share a few other cool ideas that are going on. There's a gem called persisted queries that instead of the client sending the query string every time, we can gather the query strings on the server, and the client only sends the name, and then we can find the query by name and execute it. Saves network, what do you call it, bandwidth or whatever, and saves time parsing, things like that. There's also a library from Shopify called GraphQL Batch that solves N+1 problems. So if you're fetching a deck and all of its cards, you can optimize those lookups. I heard on a podcast that GitHub has an idea for a view layer that each partial would specify its requirements with GraphQL. And then before rendering the view, you could gather up all of these things together, run one query, and then render the view. Sounds very interesting. And I hope I've made you interested enough that you'll check it out and see what you can build with it, because I think it has a lot of possibility to simplify application development. I'm all done. That's where you can go to read more. And I brought stickers that have this logo. The company Sticker Mule is using GraphQL, so they made us some free stickers. So if you'd like one, come say hi, and I'd be happy to give you one. OK, thank you.